Big O notation. What is Big O notation? Big O notation with a capital letter O, not a zero, also called Landuas symbol, is a symbolism used in complexity theory, computer science, and mathematics to describe the asymptotic behavior of function. Basically, it tells you how fast a function grows or declines. Landuas symbols comes from the name of German number theoretician Edmund Landua, who invented the notation. The letter O is used because the rate of growth of a function is called its over. For example, when analyzing some algorithm, one might find that the time or the number of steps it takes to complete problem of size n is given by t n equals 4n squared dash 2 n plus 2. If we ignore constant, which makes sense because those depends on the particular hardware the program is run on, and slower growing terms, we could say t n grows at the order of n squared and write t n equals 0 n squared. In mathematics, it is often important to get a handle on the error term of an approximation. For instance, people will write ex equals 1 plus x squared slash 2 plus 0 x 3 squared for x to 0. To express the fact of the error is smaller in absolute value than some constraint times x 3 squared if x is close enough to 0. For the final definition, suppose fx and gx are two functions defined on some subsets of the real numbers. We write fx equals 0 gx, or fx equals 0 gx for x. To be more precise, if and only if there exist constants n and c such that fx c gx for all xn. Intuitively, this means that f does not grow faster than g. If a is some real number, we write fx equals 0 gx for x to a. If only if there exists constant d to 0 and c such that fx c gx for all x with x to a. The first definition is the only one used in computer science, where typically on positive functions with a natural number as argument are considered, the absolute values can then be ignored, while both usages appear in mathematics. Here is a list of classes of functions that are commonly encountered when analyzing algorithms. The slower growing functions are listed first. C is some arbitrary constant. Notation to name. 0, 1. Name constant. 0 log n logarithmic. 0 log n c polylogarithmic. 0 n linear. 0 n squared quadratic. 0 n c squared polynomial. 0 c n squared exponential. Note that 1 n c squared and 0 c n squared are very different. The latter grows much faster no matter how big the constant c is. A function that grows faster than any power of n is called super polynomial. One that grows slower than an exponential function of the form Cn is called sub-exponential. An algorithm can require time that is both super polynomial and sub-x polynomial. Examples of this include the fastest algorithms known for integer factorization. Note to that 0 log n is exactly the same as 0 log n c squared. The logarithms differ only by constant factor, and the big O notation ignores that similarly logs with different constant bases are equivalent. The above list is useful because of the following fact. If a function fn is a sum of functions, one of which grows faster than the others, then the faster growing one determines the order of fn. Example, if fn equals 10, log n plus 5 log n 3 squared plus 7n plus 3n squared plus 6n 3 squared, then fn is equals to 0 n 3 squared. 1 caveat here: the number of summands has to be constant and may not depend on n. This notation can also be used with multiple variables and with other expressions on the right side of the equal sign. The notation f n m equals n squared plus m3 squared plus 0 n plus m represent the statements ECEN ANM 2n MN M n squared plus m3 squared plus c n plus m.